Welcome back to this tutorial. In the previous tutorial, we create the neural network, the update function that is the most important artificial intelligence function that we'll be using. But now we'll need to create the genetic algorithm, the mutation, the crossover, and that stuff. And also create the constructor of the neural network with a DNA for assigning them to the values. So we have here the window that where we create the neural network. Okay, we create all this code that is the same as in the previous tutorial. So now we need to create the DNA, remove this extent, okay, and this function as if in the neural network, and we need to create some variables, the class variables that will be the float that is the same list as the weights, because the DNA will be the weights of our neural network. So this is the DNA. Also, we will have the private float mutation prop that will be 0.1. This is the most simple way to create the genetic algorithm. But if you want to create my as my project, I have created like a mutation rate for making better individuals. Also, we'll create another private float that will be the max variation and the private float max mutation. Perfect. And now we need to create the constructor of the DNA that will have as parameters the list of weights, okay. And now we'll have the public the getter of getting the DNA that we'll be using, and we'll call it get DNA, and we'll return the DNA. Perfect. And now here we'll also need to put this .dna equals to weights. And now we'll start with the main important functions. Okay, that will be the DNA, the mutation. We will return the DNA, mutated DNA. So here we'll need to create the new DNA that will be a float that will be called a new DNA, for example, equals to new list of float perfect. And now the loop for iterating through all the layers, that will be the same, the DNA.count. And now we'll need to get the weights array of the layer that will be DNA in position I, and a new loop through all the weights layer dot length. Okay, G++, and we need to create one more loop, because here we'll have to get the count as the weights layer in position G. Okay, wait, we have here an error. Weights layer. Yes, it's this weights layer. Okay, we'll continue. Dot k plus plus, and we'll need to put here dot length. Sorry. Perfect. And now we'll create the random value for the mutation. I will create a range, but it's better to create little variations between the value that is currently in the weight. But we'll create for now a value between 0 to 1. Okay. And also for knowing the probability. This is because the mutation probability. And if this mutation probability is reached in the position jk, we'll put a random dot range between minus max variation, comma max variation. You can also put here plus equal, okay, but before the fact I have explained before, I wouldn't put it. So we have finished, I think. Yes, here we'll put the new DNA dot add the weights in the ledger and return new DNA of the new DNA data. Okay, so we have the mutation, and now we'll need to get the crossover. Okay, that is very similar to the mutation, but with two parents. So we'll return also a new DNA, and we'll need to pass the other parent, because as you know, we are in the class of the DNA, so we have currently a new DNA. So we have the DNA of the class, and that is one parent, and the parameter that is here, that is the other parent of DNA parameter, that is and also a parent. So we have the two parents that we need to use. So here we'll create as the other the mutation, the child, okay, of the two parents, of the both parents, with this child. Okay, so we need to iterate. I mean, it need to be less than dot count I plus plus, and we need to create to get the layer weights. So one parent layer, that is the parameter. Okay, other parent. So we need to put other parent dot get DNA, and we have created, sorry, DNA in position I. Okay, and the parent that we are currently in the class, that is the weights layer, the parent layer, better, two difference between the two parents. So we need to put this dot get DNA, or just you can put DNA because it's here, the DNA. So DNA better in position Y, I, sorry. And now the two more loops we must do. Wait. other layer, no, parent layer dot length and g++, get also the last 4, that will be this, but with the parent layer dot length, but in position g. Okay, and k++. Perfect. So now we need to get between the range of 0 and 1, because here we have the mutation probability, but we will assign the crossover between the two parents 50%, okay, of probability. It's better, I think, to put more DNA from the best parent than from the second, but do this as whatever you want. I will put rand must be less than 0.5, but you can change this value to other number between 0 and 1. So we need to put now parent layer dot j position jk equals to other parent layer. So the output will put in the parent layer, okay, but this is for saving space and variables, but we could also create a new variable, but it's unnecessary. So okay, in the else, as I said, we are putting the values in the current parent layer, so we don't need to put anything here because we'll put this. If you want, I put it parent layer dot j dot k equals to parent layer dot j dot k. So it's the same, okay, because we are replacing the values to the same variable. So here is the same. So this is the first parent, and this could be having the DNA of the second parent. But this is a position only, okay? All the DNA will be extracting different genes from both parents. And now here we will need to put child.add. Wait, this must be here out of the two loops. Dot add a parent layer. Perfect. And we must return here the DNA. Return new DNA. So we have created the most important of the genetic algorithm functions and also the neural network. But as I said in the previous video, we need to change this DNA, this constructor, because we have two. So we will start creating it. Okay. It's simple. It's not difficult to do, but we must do it. So we have here the total layers, but here up we need to put the list of floats that will be the weights of the DNA. So here weights DNA equals to DNA dot get DNA. Okay. Now this is the same. All this stuff are the same, but we will change here. Okay, we will not set up the random value. We'll put the DNA values to the network. So we need to put layer weights in position G and in position K equals to DNA weights DNA. Okay, and wait, yes, it's fine. So weights DNA in position, we'll need here to get the layer of the weights. Okay, so weights layer, no, right here, weights DNA layer. Okay, and this will be assigned better here. Okay, so weights DNA will be okay. No, we need to put a weights DNA layer. Will be equals to weights DNA in position I. Yes, now it's right. So here we'll put weights DNA layer, and now here we must put the positions. So JK. And I think we have finished. We have the genetic algorithms and the neural network that are our artificial intelligence stuff we will be using. So in the next videos, we'll start creating the visual of the application, but the most complex things are already done. So hope you like the video and you have created the neural network and the genetic algorithm.